Input-output boxes. Your learning target today is I can find the pattern in an input-output table to complete the table. I'll know I'm successful today when I can find the rule of the table by thinking of all four operations and finding which makes sense with the pattern, and then filling in the missing numbers. So we have some more practice with those input-output boxes. And so here's our first problem for today. Just like with yesterday, I have some missing information, but I have just enough information right here that I could try to figure out the rule and the pattern. And I can with this information. So let's look at the input, which again, what did I say yesterday input or in kind of meant? It kind of meant like before, right? The in is the before, and the out or the output is the after. So after the rule that, whatever that is applied, then it turns into that number. So looking at the before or the input, let's look at the first one right at the top. We have 21. And then at the output, it turned into 15. Well, what happened right there? It looks like definitely the number went down. And I know if it was division, 21 and 15, they don't belong in a fact family together. That wouldn't make any sense. So of all the four operations, I know it's not adding because the number doesn't go up. And same with multiplication, the number doesn't go up. And like I said, it doesn't make sense with division, so it must be subtraction this time. Okay, well, let's make sure that we are right by looking at the other ones too. But what are they subtracting by, does it look like? At least for 21 and 15. 21 minus something equals 15. Well, 21 minus 1 would be 20. And then if you take away 5 more, it's 15. So that means they took away 6. So it could be a minus 6 pattern. Let's see if that works for down here. 26 turns into 20. 26 minus 6 is 20, so that rule works right there too. So I would say, since it worked for those two, that our rule is subtract 6 or minus 6, right? That would be our rule. So let's look at 32. And we know that the output, we have to subtract 6. 32 minus 6. So 32 minus 2 would be, of course, our 10, which is 30, right? And then we have 30 minus 4, and that gets us to 26. All right, so 26 goes in the output for there. And then for the last one, we are actually given the output right here, 38. That was the after the rule, right? So that's when you subtracted 6, you get 38. So that means my input's a bigger number. Well, what would I have to do with the opposite? To find the opposite, I could just add 6 to my 38 right here. And you will see how that will still work with the minus 6 rule. Okay, so let's add 6 since this is the after and we need to try to do the opposite. Okay, so what's 38 plus 6? Well, let's see. If I split my 6 into a 2 and a 4, I would do 38 plus 2 is 40. And then 40 plus 4 is 44. Okay. Let's see if that would make sense. 44 minus 6 is 38. Well, 44 minus 4 is 40. Minus 2 more is 38. So, yep, see, that works. When I'm given the output, remember, in order to find the input, just kind of do the opposite. The opposite of subtracting is adding. All right, here's our next one. This time, I have a lot different looking input-output table than I had before. And so let's take a look at our before or our input, right? Before the rule, whatever that is applied. We have a large number, it looks like. We have actually large numbers, right? We have 21. We have something we don't know yet. We have 56, and we have 63. And then after we apply the rule, the number gets a lot smaller, it looks like. The only one I know for sure is 63 turns into a 9 after the rule. So I know when I look at all 4 of my operations that we've been working with all year, I know that I will not be adding, that's for sure, because my number in the output gets a lot smaller. So definitely not adding. And that also means that we are definitely not multiplying because, again, the output is smaller. If we were adding or multiplying, the output would be larger than the input, and it's not this time. So we have 2 possibilities. It could be subtraction, or it could be division. What do you think so far of what it could be? Why don't you pause the video and have your teacher pause it and talk about what you think and why? Okay. Well, I hope that you, in order for you to make this decision, that you noticed maybe a pattern with fact families, right? I know that, yes, my numbers get smaller, but I know just from practicing a lot lately that 63 and 9 are part of a fact family. And so are some of these other numbers. If I notice, like, oh, I know a problem where this could be an answer, and I know a problem where this is the answer. I know this is a tough one, but I hope that you thought of 63 and 9 being related. So actually, this is a division rule for sure. And 63 divided by 9 is going to be what our pattern number is, because we know 63 divided by something equals 9. And we know when we divide, we can kind of flip that around and go 63 divided by 9 is that number, right? It's like saying the same thing. And 63 divided by 7 is 9. So our rule is divide by 7. And that is our pattern. So I have to divide 7 as my rule, and then I'll get my output. Let's look at 21 divided by 7. That would get me 3. And let's go down to 56. What's 56 divided by 7? Oh, well, I know 7 times 8 is 56, so 56 divided by 7 is 8. That's a tougher one. But think of it as a multiplication problem, and then you know that, oh yeah, multiplication and division, they're similar, so that will help you. Okay, last but not least, we have 6 that I'm going to put in this red box. We know that that's the after. So that's after we divide by 7. So something divided by 7 is 6. Or, since 7 and 6 are my small numbers, I could just ask myself, what's 7 times 6? That's the same thing as saying, oh, something divided by 7 equals 6. Because we know our product is the big number in each of those problems. And that is 42. So that is our completed input-output table when we divide. So just think of your fact families that you know, and that might help you decide, oh, I'm going to divide and not subtract this time. All right, so before you pause the video and try this last problem today out on your own, I want you to think about again, what's the pattern or what's the rule that you are noticing? Think of the 4 operations that we have worked with and eliminate the ones that don't make sense, okay? Notice what's happening before we apply the rule in the in, and notice what's happening after in the output, and eliminate the ones that don't make sense. And then test out what you know and find that pattern and that rule. And then I want you to fill out the rest of the table. So please pause the video so that you can figure this out, and then resume the video when you have it all figured out and want to check your answer. All right, I hope that you were able to do that, and I really hope that when you looked at the 4 operations and you eliminated what didn't make sense, you noticed that in the input we have a small number, and then out we get a large number. So that means we are definitely not going to subtract. We are definitely not going to divide, because if we did those two things, we would have a smaller output than an input, and that's not the case. So it's either that we're adding or we're multiplying. Well, think of what you know about fact families, kind of like with that last one. I know that 8 and 72 are part of a fact family, and I do know that 3 and 27 are part of a fact family. Not only that, but look and see. Let's eliminate another choice. When I have 3 turning into 27, what number would I have to add? Well, I would just do 27 minus 3 to figure that out, which is 24. So 3 plus 24 is 27. So I could say, okay, is that a plus 24 pattern or a rule? Is 8 plus 24 72? Does that make sense? What is 8 plus 24? Well, 24 plus 10 is 34. Minus 2 is 32. So, not 72. 32. That's off. A lot, way off. So, it's not a plus 24 pattern. It's not addition then. That means it has to be multiplication. So, it is a multiplication rule for sure. And multiplying by what? Oh, well, that fact family, 3 times 9 is 27. And I know 8 times 9 is 72. So the rule is multiply or times 9. Multiply by 9. And so let's figure out the rest. We have 4. What's 4 times 9? 36. And then to figure this out, what times 9 is 54? Or I could just ask myself, what's 54 divided by 9? It's the same thing. 6. 6 times 9 is 54. Or 54 divided by 9 is 6. That will work. So yes, our rule is multiply by 9. So remember, your learning target today is I can find the pattern in an input-output table to complete the table. And you'll know you're successful when you can find the rule of the table by thinking of all 4 operations and finding which makes sense with the pattern, and then filling in the missing numbers.